So when would you like to start?
Uh,
Uh,
so now start, sir. Uh,
Now, how many still left to join?
I think the other member will join soon, sir. So
Okay. Let me wait for 5 minutes.
okay, sir.
So, thing I like to know first, who are the participant here? Student, faculty,
Student,
student or faculty or both?
sir, both, sir. The student and faculty.
Both. And those who are student, which year particularly?
It's like a second year, third year, sir. Mostly the student will participate. Final year
Means
also, sir.
no, that means the fourth to fifth semester, those who are reaching six to seven, these two.
Second year.
These are completed fourth semester. Now they will in fifth
Yes,
semester.
yes, sir. But examination is not held till now, sir. So they are
Oh, final year.
yeah, they are still in second year. After
Oh, that means fourth, sixth, and eighth. Fourth,
yes,
sixth, and eighth.
yes, sir. Fourth, sixth, and eighth semester.
Hmm. And do you have any in your curriculum CAD paper, compulsory paper?
Yes, sir. That in seventh semester, sir.
Uh-huh.
CAD cam section is there, sir. One syllabus, sir.
No.
Curriculum.
CAD cam theory paper or sessional lab?
Lab and theory both are there, sir. In seventh semester.
Both are there.
Yes, yes, sir.
Seven, it's compulsory.
Yeah, is compulsory.
Okay. Can the concerned teacher can tell me what are the syllabus you're covering in your CAD CAM subject?
Yes, sir. I am taking the CAT subject, sir. So
Oh, you are.
yes, sir.
So, what are the general topics is there, or which book you are basically syllabus is based on which books, or what are the
Sir,
books you are?
if you're talking with lab, sir, we are focusing on AutoCAD and CADIA software in lab, sir. And that in theory paper, sir, that one writer is there, so we are follow that book, sir. And several writer is there, sir.
But I am talking about whether like the topics like computer graphics, geometric modeling.
Yes, sir.
So,
In theory, sir, they are asking like sir, uh, wireframe,
wireframe modeling.
and then we have to write the some enclosed area. They are giving the some point and they derive the some equations like differential equation like that, sir. And
Uh-huh.
I will show you, sir, the level of the question, university paper question. So you can.
Yes, okay. After that, after the session, you can just show me
Okay.
according. Hmm.
Okay.
Means
And
after the today's session.
yes, sir. I also show the syllabus, whatever you have covered right now.
Uh-huh.
So let us start. Every slowly participant will add, sir. I think in net someone having the network issue like that. Okay, now very warm good afternoon to all of the participants. It is my privilege to be part of this 5 days workshop on computer-aided design for mechanical engineering. Our keynote speaker is from NIT Dr. Sibendu Shekhar Roy. He is a professor in NIT Durgapur, and he has published several research papers and having the paper patents also, and also they are collaborated with some other project, and his expertise in CAD, CAM, and robotics, and in industry point of view and gender teaching point of view. Also, CAD/CAM is a very vast subject and very important for the student also. So now uh, this session I hand over to the Dr. Sibendu Shekhar sir. So now, sir, let us start your session.
Okay. Let me see.
Every participant, please mute your mic. So no noise will come from your side. Okay, now we start, sir.
Okay. Yeah. Okay. Okay. Very good afternoon to all of you. So, first of all, I like to take the opportunity to thank Professor Ronjit Roy as well as the Dr. Ashish Naran for giving me an opportunity to share some of my knowledge with you in this particular area. As Professor Ashish mentioned that today's topic is the computer-aided design for mechanical engineers. So let me start that with the brief introduction. So being a mechanical engineer, because I have also passed mechanical engineering, so aim of mechanical engineers, and based on that we like to establish why this particular topic is important with respect to the mechanical engineering. So as you know, the aim of mechanical engineering is to an application of engineering science and more specifically the physics, mathematics and material science to design, to analyze, to manufacture, and to operate and to maintain the different product. Product may be devices, machinery, or the mechanical system. So, it's a broad objective or the broad aim of mechanical engineers to apply the principle of engineering sciences, and that means the law of physics and the material science with the material handling system or medical devices also, that the healthcare devices which is basically designed and manufactured by the mechanical engineers. Along with that, biggest discipline, many things. Main task is to design the product or analyze the product, manufacture the product. Now, if you see quickly that mechanical main domain the side is the design engineering, where the subject knowledge like vector mechanics, solid mechanics, theory of machine engineering, mathematics, computer science, and the fracture mechanics. This particular basic subject or fundamental subject knowledge is required for design engineering. Another is once you design your product, you have to manufacture that one. Or in order to design the product, many analysis is required. If it is a energy stem in mechanical engineering, then fluid and thermal engineering is required. That fluid, this is another broad area in mechanical engineering, fluid and thermal engineering, where thermodynamics and fluid mechanics knowledge is predominant. And third most important domain in mechanical engineering, or that is the production engineering, it covers both manufacturing technology and the industrial engineering. And here I have mentioned the out of these three broad areas, what are the modern trends in design engineering, the application of CAD/C, design optimization. Similarly, in fluid and thermal engineering, there is application of CFD. In the production engineering, there is application of the your computer manufacturing. So, but in this particular, out of these three broad areas, the portion we like to concentrate here is the design engineering, and in design engineering is basically fundamental knowledge required to do the design activities is the mechanics. So without mechanics, we cannot design any of the mechanical engineering product. So as you know, that mechanics it's basically covered in your engineering sciences classes, and it is broadly classified into three groups, and these three class of mechanics is required for mechanical engineer. The very first mechanics is required, mechanics of rigid bodies. So that we already know, the mechanics of rigid body is basically in the name of engineering mechanics that used to taught in the first semester BTech course, but is the very first step of design activity to understand mechanics of rigid body. Here the main assumption is that we assume that our body is rigid, but in practically no such body exists which is rigid. But for simplicity in our calculation, so we have assumed the body is rigid. That means the distance between any 2 points in a body will not change due to the application of the force or application of the load. Is the assumption. Based on this assumption, the mechanics has been developed, that is called the mechanics of rigid bodies. And this assumption is very important assumption in order to separate kinematics and kinetics. So this is a very important assumption based on which we basically separate the two subdomain, kinematics and kinetics. Otherwise you cannot separate this one, because if you apply the force, certain amount of force will be responsible for your motion, and a certain amount of force is responsible for its deformation. But if you can consider both the thing initially, it is very difficult to find out the how which particular portion of the force is responsible for the motion. And that is why, in order to simplify our calculation, we assume initially the body is rigid and the entire force is useful. The body is resistant enough so that entire force is responsible for your motion. Now, based on this assumption, we have seen the kinematics and kinetics, and if the body is motion, if it is body in static condition, the problem is known as a static. Now, extension of this concept, that in, as you know, the engineering mechanics, we have learned that kinematics of a particle, after that the kinetics of the particle, then kinematics of a rigid body, then kinetics of a rigid body, and extension of that one is basically multi-body mechanics. When the two bodies or number of bodies is connected through the joint, it form a multi-body, and that is called the multi-body mechanics, and that has been learned in your theory of machine class or the mechanism class, theory of mechanism class. So which is nothing but a multi-body mechanics, and it is extension of mechanics of rigid bodies. Now if you see what are the laws we are applying mechanics of rigid body, that basically based on the two school of thought. One is Newtonian mechanics. So one school of thought to solve your mechanics, rigid body mechanics problem is the force balance equation, that is based on the Newtonian mechanics. Another school of thought is the energy balance equation, based on the energy balance equation, that is called the Lagrange equation, or based on the concept proposed by the Lagrange. So Lagrange method is basically energy based or energy balance method. When the rotary motion will come or the rotatory body will come, then Euler equation is required, and that is why the mechanics has been called, these two class of mechanics called Newton-Euler mechanics, another the Lagrange-Euler mechanics. That means whole mechanics of rigid body will solve by two approach, either Newtonian approach or Lagrangian approach, which is modified by considering the rotary body, that is Newton-Euler approach, and the Lagrange-Euler approach. Now we just see fundamentally that once you solve the kinematics, that means during solving the kinematics, we will not consider the cause of motion. But when you solve the kinetic, then you find out that what the magnitude of the cause of motion, that means the force and the torque. That means in kinematic analysis, we will basically build the relationship between the input and output motion characteristics. That means motion characteristics, or which is also known as kinematic parameters. The kinematic parameters we are dealing in kinematics is the most fundamental kinematic parameter is the position, and from where you will get the displacement. Then time derivative of displacement is velocity, the time derivative of velocity is acceleration, and time derivative of acceleration is the jerk. So this four quantity we will analyze in kinematics. Once this kinematics you have solved, then you have to go for the kinetics. The objective of the kinetics is to find out how much force or how much torque is required to get the desired motion characteristics. Desired motion characteristics mean desired displacement, velocity, acceleration, and so on. So that means ultimately your objective is to find out, after solving the kinetics, you have to find out how much torque and how much force is required to get the desired motion characteristics. Now, once you know this one, how much force and how much torque is required, now question will come, in order to whether that particular force and torque can be sustained by your real or the physical model, because it is made of a material which is not rigid, it is rather it is the deformable bodies. So next mechanics, important mechanics, is the mechanics of deformable solids, which is the subject name may be solid mechanics or strength of material. Now purpose of the strength of material or the mechanics of deformable bodies is to find out the internal effect due to the external loading. Now from where you are getting the external loading, the previous calculation, that means in the kinetic calculation, you know how much torque and how much force is required. Now next question will be whether a particular body can sustain that amount of force or torque, and how you know that whether it can be sustained or not, through the internal effect analysis. Now what are the different parameter by which you can analyze the internal effect? So like one such parameter is the stress, maybe a deflection. There are the different type of stresses. So these are the internal effect due to the external load. What are the internal effect? And you know from the material property that how much stress it can be sustained from your UTM data or UTM result. And if you compare, you can find out the safe dimension, or you can check whatever dimension or whatever shape and size you have chosen, that is the safe one, to this internal effect analysis, that means a stress analysis. So input for your solid mechanics is the output of kinetics is the input for the solid mechanics. So you see the sequence. In the solid mechanics class, even if it is a static problem, then even if your body is in static condition, then also first you have to solve the static problem. That means how much force is acting on that particular stationary body, and now that particular force, using that force, you have to check what will be the internal effect. So if you see the sequence for the analysis, first you have to solve either static or kinetics, depending on whether the body is in static or in motion. And after solving this, you know what are the force acting on an individual component of a mechanism, and you just check what will be the internal effect due to this loading pattern, and that can be analyzed based on your mechanics of deformable solids. So from here you can conclude that output of kinetics will be the input for your solid mechanics. So this is the next class of mechanics, which is also important from the design engineering point of view, that is the mechanics of fluid. There are the many machine elements like bearing, fluid coupling. So these are where the fluid is used, and that is why mechanics of fluid mechanics the fluid mechanics is also important in respect of your design engineering. So with this fundamental thing, what are the mechanics is required. So we can proceed for the what is design, because in this particular topic, computer design, one important keyword is the design, and here we like to specify the design in the domain of mechanical engineering. And Professor, may I audible? Hello.
Yes, sir, you are audible.
Okay.
Yes, sir.
Okay, now I like to say, again, I like to briefly introduce that what is design. Though all of you know that one, but for the student in general, as you know, the design is basically a problem-solving process. It is the process of solving the problems. So we have many problem in our society, but one problem is the design problem. And now design problem, it's not only belongs to the mechanical engineering. So design problem is solved by your fashion designer, because they are designing the clothes. They are the legal advisor. They are also solving the design problem, because they are solving certain case that has to be designed. So, but we engineers, the solving the design problem means that electrical engineer will design the circuitry, computer engineer will design the computer architecture, so your electronics engineer and computer engineer will do that one. Similarly, civil engineer deals with the design of a bridge, structure, dam. Chemical engineer deals with the different chemical plants in piping system, or the design of materials for metallurgical engineer, or that is synthesis. But we mechanical engineer deals with the mechanical engineering design. So so design, one a subset of design engineering is the engineering design. Within the engineering design, we mechanical engineers we basically on the mechanical system design. Now, any design problem, it is the decision making process. For example, if you like to design, or if you like to decorate your room, or you want to decorate your car, that means it is also a design problem. You have to take decision that whether, in order to decorate your room, what will be the color you like to use in different walls, whether you will use the same color in all wall, or you can use the different color in the different wall, or whether you like to put the picture of in the wall, you like to put the picture of Sachin Tendulkar, or you like to put the picture of Virat Kohli. It is your choice. So in order to design your room, you have to take decision. So similarly, in engineering design also, you have to take a decision. So design in the decision making process, and it is the iterative process that I will tell you afterward. It's not straightforward. Many iterations you have to do in order to finalize a particular design. And obviously that design is the creative process. Just if you like to decorate your room, or if you like to design your building, then you have to have a creativity. So some innovation, some creativity is required. So design is the innovative and creative process. Now in layman's language, you can say design is to formulate a plan to satisfy the particular need, and to create something with a physical reality. So this is the in crude way you can say design is to follow a plan to satisfy the particular need, and to create something with physical reality. Now we like to define the design in respect of mechanical engineering. So mechanical engineering design, there is a one subset is called the machine design. So mechanical engineering design is the broad area, out of which one subset is the machine design, and it used to in a BTech level course, that is the machine design. So whatever may be the case, whether it is a total mechanical engineering system design or the machine design, the objective of the designer is to design and develop a product may be device, machinery, or any mechanical system, or the process that is functional, safe, reliable, usable, manufacturable, competitive, and marketable by applying the various scientific principles. So without any scientific principle, you cannot design a product or a process. And along with that, you have to use different engineering tools. One tool you already know, the mathematics. Mathematics is the tools for analysis. So mathematics is everywhere, mathematics is required. And another tools which is very much used in design engineering, that is the CAD CE tools. So CAD CE is basically nothing but a tool which is full of mathematics, or full of the physics as well as the mathematics. So this is the objective of the mechanical engineering design. Now there are the two stem in mechanical engineering system. One is the energy stem in mechanical engineering, another is the structure and motion stem in mechanical engineering. Now, energy stem in mechanical engineering covers the design of refrigeration and air conditioning, design of IC engine, design of boiler, design of air compressor, gas turbine. As you know from the mechanical system we are talking about here, so predominant subject knowledge required to design this one is the thermodynamics, heat and mass transfer, combustion. So this technical knowledge is required to design this sort of mechanical system, and this one is called the energy stem in mechanical engineering. Next, as the structure and motion stem in mechanical engineering. So it covers design of gearboxes, design of belt drive, design of your you can say the chain drive, design of suspension system of the car, design of different machine structure, and it is clear from the mechanical subsystem that we are talking about. In order to design that one, the predominant subject knowledge is required: engineering mechanics, that means static, kinematics, kinetics, and it also requires the solid mechanics. So these are this particular subject knowledge is predominant in order to design this gearbox or machine structure or suspension system. And this particular class, that this particular subsystem, like the structure and motion stem in mechanical engineering, covers in machine design class. So mechanical design applies to design in the mechanical engineering system where both the stem can be involved, whereas machine design is a subset of the mechanical design where focus is mainly on the structure and motion stem only. And that is why you have seen in the undergraduate course we'll cover this sort of things: design of shaft, design of coupling, design of different gears, the design of springs, design of belt drive, chain drive, gear. So these are the brake, clutch. So this structure and motion stem of mechanical engineering, this particular topics has been covered in machine design, and that is why machine design is a subset of the total mechanical engineering system design. And because in machine design we are not covering the energy stem, we are not covering the design of refrigeration, IC engine and boiler. So machine design is a subset of mechanical engineering design where focus is on the structure and motion stem only. And here also in this particular class, we like to, a particular session, we like to concentrate on application of the tools like the computer design tool in the structure and motion stem in mechanical engineering, or more specifically in the machine design problem, or the machine design problem we'll cover in this particular session of the CAD. Now, whatever may be the case, the mechanical engineering design or machine design, whatever may be the case, the use it nothing but a use of scientific principle, technical information, skill, and imagination in the description of the configuration of the mechanical system or machine to perform a specific function. And from that point of view, a designer should have a sound knowledge in the principle of basic engineering sciences. He or she should have the technical information of basic element of machine like fasteners, gear, belt drive, bearing. He or she should know the relative advantage and disadvantage of basic elements and their suitability in the different applications. Along with that, the one most important thing for the designers is he or she should have a skill and imagination, and also the engineering judgment to give the birth of a configuration. And that is why intellectual part of any particular machine or the constructing a machine is a creative in nature. Design is a creative process, and also the design engineer is called basically the mother of engineering, because the intellectual part of any particular product is the brainchild of a designer. And in order to do that, along with the technical knowledge, the designer should have engineering judgment. Now, for example, what are the general steps in the machine design? If you see the general steps involved in the machine design problem, then you can understand so why the different tools are required. For example, here I like to talk about here any new product development. So any new product you like to develop or any new machine you like to develop. Now, what are the steps you have to follow? Very first step that you have to follow for any new product design, you have to identify the needs. So why there is a need for development of a new product. So this is the first thing you have to realize what the need. So need might come from the manufacturer end, or a need might be from the customer point of view. So in this respect, I like to give one example here. I think all of you know this one. Let us say this is a basically bowling machine, and the you see the, I think all of you know this batsman in the world. So he's basically Bharat Ratna Sachin Tendulkar. Now Sachin Tendulkar is in the front of a machine, and this machine is nothing but a bowling machine. But it is not a product of Sachin Tendulkar. It is basically product of mechanical engineers. Now my question is, why such machine is required? So he was the greatest batsman most of the time in his career. So still, once upon a time, he has faced there is a need of bowling machine, because it's the customer. They had the Sachin Tendulkar is the customer, and he realized there is a need. Now, what are the needs? If you can, I don't know your age group, but in my time. So once upon a time, we have seen that Sachin Tendulkar has to face the fastest bowler in the world, as you know, and that his time, the fastest bowler in the world is the Brett Lee and the Shoaib Akhtar. Their bowling speed was 160 kilometer per hour, and he has to face that bowling speed in ICC tournament. But you know the dedication level of Sachin Tendulkar. He has to practice similar type of ball in net session, because he is a relatively dedicated player. Without practicing, he never go to the field. But how he will practice, that is the question. So in that particular point, that particular time, the Indian fast bowler was Venkatesh Prasad, and the Venkatesh Prasad bowling speed is slightly higher than our Anil Kumble's bowling speed. So a speed might be the 135 kilometer or like that. So practicing that one, it is very difficult for him also to face the bowling speed of 160 kilometer per hour, and that is why. So there is a need for the Sachin Tendulkar to practice the bowling speed of more than 160 kilometer, and that is possible at that particular time by the bowling machine. Bowling machine, it basically you can set a particular parameter, so it can bowl maybe consistently 160 kilometer per hour or even more than that. So that means there is a need of bowling machine for him. So not only this one, bowling machine is also for other player. For example, a particular player is weak in a particular bowling. So let us say leg side bowling, a particular batsman is weak, but he has to rectify that particular weakness, and that means how he will rectify that by net session. He should practice similar type of ball number of times, and he has to rectify. No human bowler can manufacture, can deliver the same ball in the number of times. It's not possible for the human bowler, but for machine it is possible. Machine can easily deliver. If you can keep the same setting, machine can easily deliver with some accuracy or repeatability. It can deliver similar type of ball number of times. So this is another needs for the machine for the batsman point of view. Now, nowadays, in the current context, that the age of T20, this bowling is much more important for the bowlers. Now, why it is important for the bowlers? Because the T20, there is a need of more number of all-rounder than a specialized batsman or the bowler. But it is a natural talent for the bowler, and bowler has to has a net session. They used to get opportunity to bowl only. But that those who are doing cricket, all player has to bat, but not the ball. So all player means all bowler has to bat. So now bowler are getting little bit less chance to practice their bowling in the net session. Rather, if the bowler can practice their batting by using machine in his home without any other bowler, then the bowler practicing the batting using the bowling machine, he or she becomes the all-rounder. So this is another application of the bowling machine for the bowler's point of view. So in this way, you have to identify the needs. There's another example I like to show you that there's another popular game in India, that is the lawn tennis, and there are also that say your Shania Mirza she has to face the Serena Williams or Venus Williams. Their surfing speed is so high, so she has to practice that type of surfing speed, and that can be possible by the tennis ball throwing machine. So there is also need of a tennis throwing machine. Now I like to show another example. Once upon a time, this gentleman has thought of a car, though the plenty of car was available in the market in that particular time also, but still the gentleman thought of to develop such a design as such a car which can be afforded by the common people, like 1 lakh nano car. Whether it has been success or failure, that is immaterial, but once they realize that need. So in this way, you have to first realize or identify, you have to the need for the development, then you have to collect information from the market survey, from literature survey, from patent survey, from web survey, and carry out the economical feasibility study. After that, you define your problem. So that means the basic problem you have to define. For example, say I like to take a example of bowling machine because it is the mechanical product. Now in bowling machine, and if you like to define the problem, let us say in your college or in your college there are the sports center or the sports club, and there let us say for student you need a machine. Now obviously if you like to design your in-house machines, so instead of purchasing this machine, the machine cost is so high, it might be difficult, but you can design your machine. But how will define the problem? The problem obviously you have to design that means the problem statement will be design and development of low cost bowling machine, or more specifically you can say low cost portable bowling machine. Why portable? You see, the machine which is in front of Sachin Tendulkar, that means it has to leap up around the height of 7 feet. You have to put it there, and once the practice is over, you put down and you keep it in your room so that it should not affected by the rain or other thing. So that is why the basic problem statement is design and development of low cost portable bowling machine. So this is your problem statement. Next is to frame the design specification. So what could be the design specification in this case? From the common way, you can easily say the design specification here for a bowling machine, obviously the bowling speed. Most important specification is the bowling speed. And if you see, relate this particular thing with your mechanical engineering knowledge, it is nothing but a kinematic parameter. It is the speed, the velocity of the ball. That is the most important parameter that you have to specify. I like to design a machine to achieve the bowling speed, say, varying from, say, 70 km per hour to, say, 165 km per hour. So this is the first parameter by which you can specify the bowling machine. Now, how will increment 70 to 165 km per hour? Whether the increment will be continuous or discrete, whether you do this with the first 70 km, 71 km per hour, 72 km, the 1 km per hour increment. So that means you have to tell the minimum speed, maximum speed. That means from there you will get the range, and what will be the step size. Next will be what type of ball you like to use, what is the diameter of the ball, property of the ball. Next you have to specify your most important is the power consumption, or whether it is electrically operated or solar operated, that you have to specify, and how much energy, what should be your target, the energy consumption should be within particular limit. So, and what type of ball you like to want, bowling you want to want, whether this machine is only for the say the fast bowling, like or straight bowling with in cutter, out cutter, or you like to achieve also the spin bowling. So that you have to specify. This is the specification, and it is from mechanical engineering point of view, you can easily quantify that particular parameter. So because any cutter, you can say the after pitching how much deviation has been taking place, how much angle. This is a geometry problem. Now, once you specify your specification of your machine, so next the most important term which you deal by it's the job of mechanical engineer, conceptualization, design conceptualization. That means preliminary design, that you can say the mechanism synthesis. So preliminary design or the design conceptual design or the mechanism synthesis, that means by which way you can throw the ball. So bowling machine means by which mechanism you can throw the ball. And in order to do that, lot of brainstorming between the different engineers, different designers is required, different engineers. It is the purely mechanical engineer's job. So how you will throw the ball, or in other way you can say by which mechanism you can throw the ball. There are plenty of solution is there, plenty of mechanism is there by which you can throw the ball. Now it is up to you which mechanism or which combination of mechanism you like to choose or you like to conceptualize, and accordingly go ahead. Now the very first step in any machine design problem or any product development problem is to make a conceptual design, or where you have to synthesize your mechanism. Now, as you can realize the which way you can throw the ball. One might be the from the mechanical engineering point of view. You can say by say the spring loaded certain thing. You might seen in your fair that there are the different bullet had been thrown by spring loaded gun. So using the spring loaded gun, you can throw the ball. So this might be a possible mechanism. Or you can say that there are the mechanism, caterpillar is used the mechanism using the rubber band. So that mechanism you can also use to throw the ball. Or we can say, or if you can allow, that student can say what are the other mechanism that you have learned in your theory machine class by which also you can throw the ball. And in order to throw the ball, you have to hit the ball or you have to rotate the ball or something like that. The way. So here you have to think whether you like to use the rotary arm shot kind of things, a arm where the ball, robotic arm where the ball has been grabbed and it will rotate, and a particular point will release the finger and ball will thrown. The bowler has been bowled similar way like to mimic by the robotic hand. That might be a solution. So already you have three identified. One by means of a spring-loaded bullet kind of thing, or it may be or the caterpillar rubber band sort of things, or you can use uh, the mechanism that I mentioned here, and any other thing. It may be a bullet, the gas pressure. Backside, you can apply the gas pressure in a cylinder, by which also you can throw the ball. That means by the way the bullet has been thrown, the actual bullet in the pistol has been thrown. So, any other mechanism that you have thought of? Those who are student or maybe final year student, because they like to complete, or they become engineer now. So if anyone from the final year, hello,
Anyone, a student, can answer this question?
any other mechanism can thought of to throw the ball or to hit the ball. For example, because you have learned many mechanism in your class, no, that 4-bar linkages, there are the quick return mechanism, slide rectangle mechanism, there are the pantograph mechanism that you have learned, no, in your theory machine class. Can you use any of the mechanism by which you can throw the ball or you can hit the ball? It may not use commercially, but you can think of. No, it is a conceptual stage.
Hello.
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 Tell me.
Good evening, sir.
Good evening.
Sir, I have an idea to throw a ball by a combustion machine, like a IC engine which works on the principle of combustion, which can blast and give the force to throw the ball, whatever would be the speed.
Okay, you have thought of this mechanism. Okay, this way you have to. That means you have to do this way the brainstorming session. It is called the brainstorming session, and in any product design, brainstorming is very important. That is called, you say nowadays management term, it is called the design thinking process. The design thinking process where brainstorming is required. You have thought of one. Any other solution or any other means or any other mechanism by which you can hit the ball or you can throw the ball? Anybody?
Sir, by the help of Geneva mechanism.
By help of Geneva mechanism, we know it. Geneva mechanism is it basically intermittent motion. No, here your Geneva wheel will rotate continuously, but Geneva they will getting the again that has also rotary motion, but intermittent rotary motion. Uh, but where you place the ball, because it's very slow, no, its motion is also slow Geneva mechanism, but you have to hit the ball so that it can get the speed of say at least 70 kilometer per hour, say. So that
Robotic arm.
that robotic arm I already mentioned. The robotic arm is the one might be one solution. Anything else, or the spring is maybe the spring loaded arm. There might be a spring loaded arm. A arm has been stretched, or the by your means of a spring. When you release the spring, it will throw the ball. Spring loaded arm can also serve the purpose. Any other?
Single slide.
Sir, we can also. Hello.
Hello.
Am I audible, sir?
Clear. Tell me.
So we can also use the hydraulic system to throw the ball, whatever
Good.
the speed.
It's a very good solution. This is a hydraulic system. By hydraulically you can throw the ball. Another student has been mentioned, that is a slider crank mechanism. You can think of that also. It's not it's a very good thinking, that slider crank mechanism, which is well known for IC engine, which is well known for the air compressor. But here it is out of the box thinking. The same mechanism you can use also throw the ball, hit the ball. So whether it will be commercially viable or not,
We can
get
we can
very
develop.
initial stage. Hello.
So we can develop hard amount of force by the hydraulic system and make the powerful
Sure.
speed.
So using hydraulic system, it is very much possible. And also somebody mentioned slider crank mechanism. I also appreciate his thinking, but because people are knowing that slider crank mechanism, that means it is for IC engine, it is for the say air compressor. But he thought of that by slider crank mechanism also we can throw the ball, because you see that in slider crank mechanism, which is used in the air compressor, input will be the crank and output is the slider. In the slider end, you put the ball 1-1, and a slider will hit the ball, and in this way you get the throwing of the ball. So even in the fourth semester level, the student can think of that the slider crank mechanism, you can hit the ball, say. So though it is not used, but still it is a good thinking, or it is out of the box thinking, that the using slider crank mechanism we hit the ball. It's a well known mechanism in the undergraduate course, no? So this way you have to identify the different mechanism by which you can throw the ball, but you have to check whether you can achieve your target specification, like say 160 kilometer per hour. And now you have to analyze each and every mechanism, like say spring loaded mechanism. You know, if you compress the spring and put the ball by means of a spring release, but if you can do this say the 400 times, due to the fatigue, spring will fail and it cannot serve the intended purpose, then this machine will not long run it is viable, because your most important mechanism is the spring, by which you can give the energy or give the momentum or give the force to the ball. But if the spring will fail by means of fatigue after 400 ball and you have to replace the spring, then it is not techno-economically viable. So that is why you have to use engineering judgment or common sense on already identified mechanism, what are the drawbacks, and accordingly you discard some of the mechanism. That way you can discard the spring loaded one, but hydraulic is a good option, pneumatic is a good option, and even the slider crank mechanism is another option. But can anyone say what mechanism is most popular in bowling machine? Anyone have seen this one, that machine that I have shown in the slide, and which mechanism is used? Anyone?
No, sir. No, sir. I haven't seen for this.
So it basically, you know, the rolling process in your metal forming, rolling process in the production engineering. There are the chapter called the metal forming processes, where there is a rolling process. There is a one process, rolling process, where the rod, angle, channel has been manufactured by the either most of the time hot rolling or the cold rolling process. So in rolling process, there is a rolling mill. Rolling mill means there are the two rolls. There is a gap between the two rolls. In this particular narrow gap, a billet has been squeezed, and it will be passed to and a shape of and it is not a single stage, multiple stage might be through multiple stage of you can billet will get a shape of a rod or channel angle, whatever the end product you need. So that rolling process, the two roller will rotate and the metal will squeeze and it will take a shape and it will move forward direction at high speed. If you see the rolling mill in your Durgapur, in any steel plant, the Bhilai, Durgapur, Rourkela, so you can see the rolling mill, the way the billet will move, enter into the roll from the one side and into the high speed it will coming out from the other side. So same concept has been used here. In between two roller, ball has been passed. In between two roller, but here difference between the rolling and here is the difference. Main difference is in rolling machine that your billet will squeeze, but roller will be intact. But in the bowling machine, ball will not squeeze, but rather roller will squeeze or roller will compress, and that is why there is a soft lining over the metal wheel. Soft lining, rubber lining over the metal wheel, and if it will rotate in high speed and gap between the two wheel is slightly lesser than the diameter of the ball, then once your ball will touch the wheels, the angle of bite, if it is angle of bite is proper, then it will try to drag the ball and the wheel itself will squeeze, the rubber portion will squeeze because gap little bit small gap and it will easily squeeze and it will just throw the ball in a forward direction. The two wheel concept, it may be the one wheel pressure pad or maybe the two wheel concept. So most of the are the two wheel concept machine, means two rotary joint. So this is the commercially available machines mechanism, but you can think of other mechanism also. Now this is the starting point of your design synthesis, but let us say for simplicity in this particular seminar, you forget about the two wheels and there are the 3-4 mechanism identified and you have to do modeling and simulation. What does it mean? So it is the 50 years back modeling and simulation means you have to develop the physical models, maybe scale down or actual model, then you have to carry out the experiment and you have to find out whether you are getting the desired motion characteristics, whether you are getting the desired bowling speed or not. That was the modeling simulation, but it is the 50 years back. But current days, that days is gone because the physical modeling is the cost effective cost, there are a lot of cost will be involved and you cannot sustain. So here modeling and simulation means by applying the mechanics, principle of mechanics, you have to model your physical system mathematically and you have to analyze or you have to write down the mathematical equation, you have to solve this equation and you will get the result by varying the different input parameter, and that is called simulation. Now how will do that one? Let us say for example, if you like to use the slider king mechanism, if you like to design a slider king mechanism for the ball throwing machine, now if you like to do its modeling simulation, now modeling simulation of slider king mechanism means, but or in say suppose you like to design and develop a slider king mechanism for the ball throwing machine. Now what will be your starting point to design? Because it's not like that arbitrarily you take the link length and you can manufacture something and you join it, you will get the mechanism by which you can get the bowling speed of say 140 km/h. It's never possible. What you have to do, input. Let us say my max target is to achieve 150 km/h bowling speed. For say example, maximum speed I want 150 km/h and minimum side let us say 70 km/h. Now always design is based on the critical situation. Critical situation means the maximum speed you are getting, that is 150 km/h. Now you know your requirement, maximum requirement is 150 km/h. Now you see slider will hit the ball and the ball will get the there will be a moment momentum transfer. Now the concept of physics and mechanics. Because of the hitting of the slider to the ball, there will be momentum transfer, and you will get the bowling speeds of 150 km per hour. Is it not can you not explain this thing by law of physics? By the law of physics means by your kinetics, like the collision between the two particle or two bodies that you know from your physics or from your engineering mechanics. Now that would be the starting point. That means you have to, in order to get the bowling speed of 150 km per hour of a ball whose weight is, say, I forgot the weight, if anyone know that one, it around 150 grams, something like that. Ball weight is 150 grams, say. Now you can, and speed is, means you know how much will be your initial momentum is required, and how much hitting is required of slider. That means how much speed slider has to hit the ball, then only you can achieve. This is nothing but your engineering mechanics. So you have to solve this engineering mechanics. Once you know how much slider speed is required, that means the time history of the slider speed, that means the slider speed with respect to time, how it is required to achieve that particular bowling speed is your input point. Now, when you know the input slider, once you know the velocity versus time of a slider, acceleration versus time of a slider, now backtrack. That means how will get the slider speed in this case? Where is your input? In slider mechanism, for this application, input end is your crank. Crank has to rotate. Now, whether you rotate the crank by hand, never possible. If you rotate the crank by hand, your own hand, you never reach that particular bowling speed or the slider speed. Now, what you have to do, that means you know what output you need, how much velocity you need in the slider, and time history of the velocity is also known to you. Now you have to find out how much crank RPM is required, constant say RPM, crank RPM is required. Now see, the problem becomes building the relationship between the output velocity of the slider and the input velocity of the crank. You have to build the relationship between these two. This is called the mathematical modeling, and more specifically this is called the kinematic modeling. That means this is the kinematic analysis. So modeling simulation means, I like to mention here mathematical modeling, or more specifically here the kinematic modeling first. Once you build the relationship, you can get how much RPM is required here in the input end. Accordingly, you select the motor, because crank has to be rotated by motor, like air compressor also. The compressor is run by the motor, so motor will rotate the crank. Now, if you, being a designer, you have to select the motor. Is the RPM is sufficient parameter to select the motor? Anyone? Suppose you select the motor to rotate your crank. Whether your RPM is sufficient, RPM you are getting from this kinematic analysis. Is the RPM is sufficient to select the motor? Anyone? Is the RPM is by knowing only RPM, can you select the motor? Electric motor for a actuator of the crank, because here actuator will be motor only. Anyone?
The distance is depending on crank speed and length of sir.
No, suppose my problem now, you have to select the motor. Through kinematic analysis, you know the RPM of the crank required to achieve 150 km per hour bowling speed. To achieve, because if you change the RPM, then your bowling speed will change. If you use the slide mechanism, then it is clear from your engineering sense that if you change the RPM of the crank, your bowling speed will change. Now, for 150 km per hour is the critical situation. That time RPM, you know, let's say RPM is 3000 RPM. Let us say RPM is 3000 RPM is required to get the 150 km per hour. Now that RPM by hand you cannot provide the 3000 RPM. Now you need motor. Now how will you select the motor? Whether this particular information, that means motor has to rotate 3000 RPM, is it sufficient to select the motor? Only this parameter is sufficient to select the motor, or something else is required?
No, sir, power
Sir, torque may be also considered for that, sir, that how much
Torque is
it
required.
will.
Along with RPM, torque is required, and power is the function of the torque and the RPM. Clear?
Yes.
Power, as you mentioned, is the derived quantity and it is the function of the torque and RPM. That means RPM is required along with the torque is required. How much torque is required at the crank end. Now you see, you are getting, you can solve your problem now. In order to find out the torque, that means the cause of motion. Torque is the cause of motion. Now, which problem you have to solve now? In order to find out the torque, which problem you have to solve? By solving kinematics, you got the RPM. No. Only RPM is not sufficient. You have to find out the torque. You have to know the torque. Now, from the fundamentals of your, fundamentals of your mechanics problem, very simple particle dynamics, you just say. Torque equal to I into alpha?
Yeah, absolutely.
Torque equal to I into alpha. Very simple particle dynamics. I am not talking about the rigid body. Rigid body formula is slightly complex. The torque equal to I into alpha. What is alpha? Alpha is the angular acceleration. Alpha is the acceleration.
Yes. Angular acceleration.
Angular acceleration. And I is the mass property, inertia property. I is the mass moment of inertia. Now, in order to find out the torque, you need alpha. Now, what is alpha? Alpha is the time derivative of your angular velocity. That means RPM. That means you have to solve not only the RPM, you have to solve the equation of the acceleration. Acceleration equation also solve. That means full kinematics you have to solve. Once you solve this one, along with your mass property and inertia property, you can use and you can solve the kinetic problem and you find out the torque. Torque is the function of both kinematic parameter as well as the mass property and inertia property. That means you have to solve kinetics. Once you solve the kinetics, you will get the torque, and accordingly you select the motor. So this process is called modeling and simulation. Now physical modeling and simulation is not at all economically viable in the current scenario of the last 20, 30, 40 years. So what you have to do, you have to solve by applying mechanics. Now you just see, if you like to do certain analysis the way we are doing in the exam hall. So for example, if you can take a pen, pencil, calculator and you can solve the kinematics and kinetics, at a particular time instant it will take. So your position analysis, velocity analysis, I don't know which method you have used. If you use a graphical method for one particular instant you like to solve, for the kinematics it will take say half an hour or the 45 minutes. Now, if you have to find out the time history, how it is varying. Let's say if you take the 1,000 certain instant, then you need to solve kinematics 1,000 multiplied by the 45 minutes. So that much time you need to solve only kinematics. Then you have to solve kinetics. A lot of computation is required. Mass, moment of inertia, all these things is required. That means in order to solve this one, it will take the 2 years to solve that particular thing. If you can do manually, if you can do all these things manually, because the time history is required. It's not like only particular time instant. Time history, how it will vary. That also you have to check. So if you like to do manually, then it will take too much time. It may be it may take 4 months, 5 months to solve a simple problem, simple practical problem, and forget about to develop product. So no company can develop product in time if you can do manually all these things. Now what you have to do? Manually, this kind of solving kinetics, if you can do, it will take too much time. But what you can do, if you like to find out the time history of that, the same calculation you have to do number of times simply. So which way you can do? Because the same equation you have to solve number of times. No, here. If you use the analytical method, vector loop closure equation, you know. So a vector loop closure equation for the position, time derivative of that vector loop closure equation will be velocity, and the time derivative of the means velocity equation will be the acceleration and so on, and you have to do the same. You have to solve the equation number of times for the to get the time speed. Now, which way instead of manually doing? Huh? Which way you can do this so that it can reduce the human effort, tedious job. Any idea? So which way you can do solve this particular problem? Anyone?
By the computer graphics.
Pardon?
Computer graphics.
Loudly, please tell. Please tell loudly.
Sir, with the help of computer graphics, we can.
With the help of computer. See, you have analytical equation. So with the help of computer programming, whether it is C, C++, MATLAB or Python, whatever may be, you write this particular equation in a code. You write the code of that particular equation. Now, you write the equation, no? The way you write the computer code based on your equation. Now the computer is always much more efficient than human being for a repetitive type of work, and that is solving the equation is a repetitive type of work. And if you write the computer code based on that equation and you can run that program, it might be a few minutes or few seconds you can get the time history of the displacement, velocity and acceleration within few minutes. If it is a high speed computer, within fraction of second you will get the say for 1000 instant or 2000 instant you can get all the profile, position, velocity, acceleration, everything if you write the computer program. Is it not? Can you realize that thing? If you write the computer code within the fraction of second, it can solve the repetitive where human being will take a lot of time, but the computer code is designed by human being only, so it will take a few seconds to solve that the repetitive kind of things. Is it clear?
Yes, sir.
So that computer programming to do this repetitive type of work like kinematic simulation, kinematic modeling and simulation, kinetic modeling and simulation, writing the computer code, that is basically known as computer-aided mechanism analysis. That is nothing more than the computer-aided mechanism analysis. And this is the very first step of CAD. Very first step of CAD means computer-aided design. Your topic of this seminar is the CAD, that is the computer-aided design. And computer-aided design, for the mechanical engineering point of view, first step of computer-aided design, the computer-aided mechanism analysis. That means computer-aided kinematic analysis, computer-aided mechanism analysis. Sorry, computer-aided kinetic analysis. Clear? And you can do, and now that code has been written by many software companies, many companies, and they are selling by means of a CAD tools or CAD software. For example, the Adams, or for example in CATIA, DMU Kinematics, or your SolidWorks, they are the motion solver. What is this? Inside nothing else. It is the whatever formulation you have done in generalized way, it is in coded form, and that code you can't see because the business strategy. If you can see the code, you can pirate it, but that is why it is locked. Graphics user interface, they have designed a graphics user interface. You can see, give the input, but inside your equation is running basically. So that is the tools, but CAD is basically the formulation, whatever you learn in your undergraduate course or maybe postgraduate course, based on the formulation in generalized way. They have written the code, they encrypt the code so other cannot see, and they instead of that they provide some graphics user interface in the front panel, and using that the user will use the software. But It is basically computer-aided mechanism analysis or kinematic analysis. As you know, the next step for the for machine design is the once you solve the kinetics, you know the force and torque, and next step is to engineering analysis. That means you have to do the stress analysis again. Here also stress analysis how will do, but stress analysis, you know, your force or torque will be input. Now you have to find out the cross sectional area. The force divided by the cross sectional area is your stress. Now this force by area for the very simple problem, you can easily find out the geometric shape is very simple. Then you can use, and it is a if your force is line of action of the resultant force, if it is passing through the centroid of the cross section, then this simplified formula is valid. Force by area equal to stress, but it is not valid when your force is not passing through the center of the centroid of the cross section, or even cross section is a complex shape. What you have to do? That time the most simple way, the way you are calculating the area. Any complex shaped 2D object, when you like to find out the area, what you have to do, you just split it that particular area into number of known elements, known shape like triangle, rectangle, circle, like that, and then you individually you just find out the area, then you assemble, either add or subtract. If it is the material is there, add, and if it is the whole is there, subtract. So that is concept of finite element. So the same thing you can do in your engineering analysis. Complex shaped object, you can split in the number of elements, in the number of nodes, and each you just apply the boundary condition and you find out the individual element, what will be the solution, what will be the output, like your deformation, and then assemble all these things, and you will get the total deformation and ultimately the stress. So stress analysis you can do by using the concept of finite element, and that is also CAD tools, finite element analysis. And there are the huge amount of computation. If you like to do by manually, is never possible, or it will take too much time, or it is a very tedious job. But if you write the code based on your that numerical methods and you can easily solve the problem at least few hours or the few days. A complex problem can be solved by few days. If you like to do manually, it will take a few year to solve this particular problem. So this is your engineering analysis using the finite element method. That is also a CAD tools. Using that CAD tools, you can do the stress analysis, you can do the vibration analysis, and this is the next step of your engineering mechanics. And what are the next of the design optimization? So design optimization here, you can say that you have to find out through this engineering analysis, stress analysis, you find out which one the best cross section with respect to certain criteria. So where the stress will be less or something like that, or weight will be less, based on which is the best one. That is the objective of the design optimization. So through finite element analysis, you can find out the best solution. So that is also the use of a CAD in this particular activity. Then design evaluation, then detailed design, in detail design of the component. What you have to do, you have to develop CAD model, the solid model. From there you can generate the 2D drawing automatically. Again, it's based on mathematics only, it's not like magic. So using mathematics you can convert 2D drawing into 3D drawing into the 2D, and then you communicate that particular design to your production engineer so that they will manufacture based on your concept or your engineering drawing or manufacturing drawing. So each and every activity nowadays assisted by computer aided tools, and that tools is CAD-C tools. Hello, may I audible?
Yes, sir. Audible, sir.
Yes, sir. Go ahead.
So each and every activity in design, whatever I have mentioned here in nutshell, is assisted by computer aided tools where you have to write the program, nothing else. Inside there is a program only, by either C, C++ or Java or Python, like using that, and that is in package form. It's called CAD-C tools or computer aided design and engineering tools. So each, and you can say it basically automate the process. Instead of manually you can do, it is basically automate the process. So that is why CAD tools to automate the design process. Somewhat it is the automate the design process CAD tools are used. So this is the background of your CAD. Or so next step, I like to don't know that the example that I mentioned, it is in video. So that in whatever till now I have discussed, that is the steps in mechanical machine design and what is the role of computer aided analysis or computer aided design. So in mechanical engineering, most of the times in our product there is a moving elements. There are the static element, and most of the time there is a moving element. So whatever maybe you just see in mechanical engineering domain, the product there is some moving elements. So that is why you have to solve static along with you have to solve the kinematics. Kinematics is the very first step along with the static, because always there is a static, because you know the definition of the mechanism says the one link is fixed in a kinematic chain. So the in definition of a mechanism, you know that one link is fixed in a kinematic chain, then only you can call that as a mechanism. At one link is fixed, that in the static link, so you have to solve static also. So you have to solve kinematics along with the static, then you have to solve, once you solve the kinematics, you know the kinematic parameter like position, velocity and acceleration, that will be input for your kinetics, and you can find out the how much force and torque is required to get the desired kinematic characteristics or desired motion characteristics. So once you solve the kinetics, so next, you know, after solving the kinetics, you get the force and torque, and that will be input for your internal effect analysis, that means stress analysis, where finite element is required. So this is the next step for machine design, and ultimately you can give a birth of a particular shape and size of your elements, of your individual element of your product or of your mechanism. Ultimately in machine design you have to give the birth of a shape and size of a component, but you remember that size you can find out from your stress analysis, but shape you have to assume. Nobody will tell the shape. No calculation will tell the shape. What should the shape? But calculate through this analysis, you can tell which shape is the better shape or best shape, that you can find out. But shape initially you have to assume whether your cross section will be circular, elliptical, hollow circular, hollow elliptical, rectangular, hollow rectangular, eye section, channel section. That is your choice, and you have to choose one by one, and you have to analyze, and you conclude which one is the best one. And that is why design is the iterative process. Number of times you have to carry out this analysis, and you have to iterate that one, and ultimately you have to conceive whether your crank connecting rod will be the eye section or the rectangular box. Both are possible. Rectangular box thing or the eye section, both are possible. But why the IC engine is eye section, connecting rod eye section? That your engineering stress analysis will explain. Through analysis, you can explain why they have chosen this one. But it's not like that. Same shape you have to use for the cricket bowling machine. You can think of a cricket bowling machine shape of the connecting rod will be different from the IC engine, because here the force requirement might be lesser than the IC engine. So that is why through trace analysis you can compare with the different cross section, shape and the size, and you can select the best one with respect to certain goal. Goal means either with respect to the weight or with respect to the manufacturing cost. These are the goal, and based on that you have to do the design optimization. So this is the nutshell, the steps involved in your machine design, and the role of the computer designer, you say computer analysis is software used to solve the kinematics and kinetics. The benchmark software, that is basically motion solver. Benchmark software is the Adams. Okay, there is a Recordine. Other than that, each software like CATIA having DMU kinematics, there are the sim designer in CATIA. There is a solver in SolidWorks. Similarly, there are the motion solver. Many people will take a little bit of license from the Adams, like sim designer is basically a part of Adams. Like that, there are the motion solver is there, so that will solve the kinetics and kinetic problem. These are the software CAD-C tools or CAD-C software in this particular domain of kinematics and kinetics. So next step is the stress analysis. You know the benchmark softwares are the ANSYS, Abacus, COMSOL. So these are the software or the CAD-C tools to solve the stress analysis, and similar kind of solver is also exist in the most of the CAD tools, so-called CAD CAM-C tools like CATIA, SolidWorks, your Inventor, Creo, or your NX. So everywhere there is a solver. So to solve the stress analysis. So anyone have any doubt up to this? Any
Actually,
query?
I have a question regarding
Hello?
stress analysis. Audible, sir?
Uh,
Hello?
audible. Tell me.
Sir, my question is
Tell
that,
me.
sir, it will show
Just off
the
this
stress
one.
failure, sir, stress analysis, then when it will fail and at what force. Hello?
Can you repeat the question? Can you repeat the question? Your call is dropping actually. Repeat the question.
Oh, there is some network issue. Sir, my
Uh,
question is regarding stress analysis, sir. I have to know about that. Will it show the stress failure? That means when it will fail and what amount of pressure it can held or when it will fail.
No,
This
as
is,
you know the stress analysis, you know the material. You already select the material in boundary condition. When you apply the boundary condition, stress analysis using CAD tools or whatever may be. So it basically you select the material, you know the material property from the data book. Allowable values of the mechanical properties is also you have to assume, or being a designer you have to select by considering the suitable factor of safety. You know the allowable stress limit. Now you once you apply the load and you find out the stresses in the different points. What are the stress? Because stress is the point your property. So each point you know the stress value. If your stress value is exceed your permissible value for a particular material and the particular application, then you can say it is the failure condition. That particular point will fail
yeah,
because the
yeah,
stress
sir. Yeah, I admit that, sir. But if we commit some mistake and that will be neglected in our view, then at that time this software will show our failure that here your parts may be failed.
No. Yeah, that color scheme they're showing the stress value, and by seeing the stress value, you can say it is a failure. No, there is a color scheme. No, the graphical representation in any your find element solver. There is a color scheme is there. No, a color by using they can show that this is the red color means this is the failure zone stress point of view. It will show that one graphically, or means graphic using your graphics color type of color. Red color basically indicate the stress limit will exceed the high stress region. Is your
Okay,
doubt is
sir.
clear or something else?
No, sir.
It
I'm
will
clear
show the
about that.
if you know if the high stress zone is shown by the red color, that stress if it is higher than is stress value also mentioned there. If it is higher than your permissible one, that means that zone is a failure zone. No,
Yes.
that particular
Yes.
zone will fail due to the induced stress, load induced stress, or the that because load induced stress will show because you are applying the load if it's not thermal.
Okay, sir.
Hello. Anyone others? Do you have any doubt?
No, sir.
Now, what are the software you know, student? Hey, curious. Hello.
Yes, sir. Yes, sir.
What are the software you know that? What are the CAD software you know?
Any
Sir,
student can
auto,
answer that question.
sir,
Hello.
AutoCAD works, ANSYS, and MATLAB.
AutoCAD is for drafting, mostly drafting purpose. If the Autodesk 3D can develop, but mostly it is drafting purpose.
Sir, some of the students know about CATIA, sir, SolidWorks, CATIA.
CATIA, SolidWorks.
Yes, sir.
So all the software like CATIA, SolidWorks, basically both are from the product of Dassault system.
Yes, sir.
So there are the plenty of module. It is in a modular form. Okay, so it is in modular form. That there are the different workbench is there, and obviously first is the part design where the sketcher is required, part design, then assembly design. So all this thing is after doing assembly design, then the good approach is once you develop, let us say for a mechanism, whether it is a 4-bar linkage or slide rectangle mechanism, first you create your, you can your develop the solid model of a mechanism, but obviously you have to know the dimension. So for that analysis, you know that the kinematic synthesis and all these things. So after doing this sort of things, you develop, because shape you have to choose. So you develop that your solid model of the different elements in part design workbench, then assemble it. After assembly, so what you can do that if you can follow the steps, many of you have learned ANSYS, that I have seen that you have replied that you know ANSYS. So at least before ANSYS, you try it that your motion analysis, because most of the time mechanical engineering static is there, static part is there. So if it is a static part, then directly go to the ANSYS. But if it is the moving part, like to do the stress analysis of the moving part, then you have to solve the kinetics, no? And that means kinematics and kinetics. So in CATIA, in SolidWorks, everywhere there is a motion solver. In CATIA, it is called the DMU kinematics, and in SolidWorks, the motion solver. So you create a joint there. You just build, create a joint like revolute joint, your the prismatic joint. You create a joint and you give the input, and you just identify there. You give the motion characteristics like your velocity with respect to time. And if you give that one, then you can find out the time history of the other kinematic parameters that graphically the software will represent. Basically, the inside the your equation is running. Equation is solving rather. So, and it is represented by graphically graphics user interface, and you will get the velocity variation, acceleration variation, and also next you go to the kinetic model. There you can get force, the how the force is varying, how the torque is varying, everything will give. And that force and torque will be analyzed properly, but because software will not analyze, the software will give the output. The software, you know, somewhere you can call sometimes garbage in, garbage out. If your input is wrong, he will get the output is also wrong output. But software will give the output. But you have to justify your answer. You have to inference. You have to draw your inference after seeing that one, and that is why domain knowledge is very important. And you will get the force variation, and from that which particular force will be boundary condition for your stress analysis, say in ANSYS. Identifying that one is very important. So you get the force history with respect to time, how a particular element force is varying, its magnitude. Force is the vector quantity. Force, its magnitude is vary, its direction may vary. Now, which particular force will be the critical one, and which it may be single, not be single one, maybe multiple point. The force will be the critical, and that force will be input. That force will be input for your ANSYS. That means for stress analysis as a boundary condition. So for a moving body. So that is why force analysis is very important, because it will be the input for your ANSYS. No, it is the input for your ANSYS or any finite element solver. In sitting in the CATIA workbench or SolidWorks workbench, you can do small simple analysis using finite element method, because they have that solver. Benchmark software is ANSYS. To tackle the big problem, you have to go for the ANSYS. But for that, applying the boundary condition is very important, and that might get from the static analysis if the body is static. it might get for the kinetic analysis if body is in motion. So that thing you have to do it properly when you like to use the CAD tools. So this slider crank mechanism, the over. So if you don't have any query, then quickly I just can few more thing in design which can be tackled by the CAD. Few more thing in design which can ultimately now go because of the application of the CAD tools. That is the aesthetic. Any product design aesthetic is very important. So it may be machine or maybe any other product. So what is aesthetic? So in machine design class, if there is a number of products in the market having the same quality, efficiency, durability, and the cost, customer will naturally attracted toward the most appealing product. And external appearance is a very important feature which not only gives the grace and class luster of the product but also dominate in the market, whether it is the automobile or the household appliances or the audiovisual equipment. You see nowadays car and a few years back or 30 years back or 40 years back, car shape you just check in four-wheeler, say the Maruti Suzuki. You see Maruti 800, what is the shape and what is see the shape? Hello? If you see the shape of the Maruti 800 and if you see the shape of your now it's a Alto or Presso or the Swift or Swift Desire, that shape is complete look is different. So, and it is which one is aesthetically beautiful? Much beautiful. The most of the cases, the modern products are aesthetically more beautiful than the previous. Even in say Hyundai, the old product, and now the i10, i20 product is aesthetically so beautiful than the previous product. It is because of the application of the different CAD tools, the aesthetically beautiful product you can develop by using the CAD, which may not be possible in the 30-40 years back. So that is called the industrial design. Similar, that concept is also applicable for the household appliances, for your audiovisual equipment or any other equipment. Now, industrial designer job is to create the new form and shape which is aesthetically pleasing, and external appearance of the product is cumulative effect of the number of factors like form, color, surface finish tolerance, materials, and manufacturing methods. And many times there is a relationship between the functional requirement and appearance of the product. For example, the shape of the Boeing or the Airbus aircraft. The functional requirement result in a shape which is aesthetically pleasing. The example is given in the Boeing aircraft or the Airbus aircraft. Evolution of the streamlined shape of the Boeing or Airbus aircraft is the result of the studies of the aerodynamics for the effortless speed, but it is also aesthetically beautiful. Second example, chromium plating on the household appliances corrosion resistance rather than for pleasing the appearance, but it is purpose the both the purpose, functional requirement as well as the appearance or aesthetically beautiful product. So aesthetic is very important for any product. So whether it is the car, whether it is the two-wheeler, whether it is any sort of electronics gadget which is used in your home or any household appliances, aesthetic is very important nowadays because as reason you already know. So next, another important thing in the design is the ergonomic consideration is very important nowadays, and that is there are many jargon they are used, many product develop that ergonomic friendly product. What do you mean by ergonomics? Ergonomics is the basically relationship between the man and machine and the application of the anatomical, psychological, physiological principle to solve the problem arise from the man-machine relationship. So topics of the ergonomics, it is the studies your anatomical factor in the design of the driver seat, and you just see now modern car. You see the modern, previously the car seat was fixed, the long back. Now what they do, they have seen the same car, it can be driver's height is, some driver height is 5 feet 2 inch, some driver height is 6 feet, some the driver is more than that. So if your seat is fixed, then the different link lane for the different height of driver is facing a lot of problems. So what there is a sliding, no? The driver's seat is now sliding. is it 10-20 years back or 10 years back car, you see the slider seat is been sliding so that it can adjust the distance between the gap between the in order to adjust the leg length, gap between the seat and the pressure pedal or the pedal of the clutch and the brake and the steering, the gap can be increased or decreased depending on the height of the drivers, or ultimately the leg length of the drivers. So that basically the ergonomics. The design has been evolved, or design has been changed in automobile industry by considering the anatomical structure of the drivers, or that is called the ergonomic design. Similarly, nowadays car have seen that not only the sliding front and front side and back side, not it also you can adjust the height of the seat. One car, it has one more facility. It is recently, or it may be 10, 5, 6 years or 5 years back. A costly car, it was there from long back, or the low cost car also they introduced that height adjustment of the driver's seat. Not only the front side and back side adjustment, it also height adjustment. There the inclination of the driver's seat. All these things is based on the ergonomics, because ultimately all machine has to be run by the human being, and that means there is interaction between the man and machine. Similarly, you just see the display panel of your Rajdut. You see those are having Rajdut. You see the display panel is such that you cannot see easily. But if you see incline the panel little bit of 30, say 20 degree or 30 degree, you can easily sitting in your seat in your when you're riding your two wheeler, you can easily see the speedometer. So that is basically a slight change in design by considering the ergonomy, human ergonomics, and also you just see gripping, steering gripping, or your bike handle gripping. There are a lot of ergonomic analysis has been done, and design has been improved. Similarly in the lever, hand wheel. So all these thing, the human, the biological thing, or the human anatomical physiological thing, consider in design, and you have to do all these things, but it is only possible if you can do physically, then it will be a wastage of money, because a lot of physical product you have to develop, and if it is not satisfied, you have to make another physical prototype, so it is the wastage of money or as well as time. But if you use the CAD software, you just see the some figure I have shown in the below. Using CAD software, you can do all this analysis, ergonomic analysis. You can easily do using the mannequin sort of thing, that solid model of the human being and the solid model of the product. You can check all these issues. So that I will tell you what the way the modern industry is doing this ergonomic analysis using the CAD tools. So there is a very important use of the CAD tools for ergonomic analysis and machine design. So manufacturing consideration is another important factor in machine design that you know, because ultimately your product has to be manufactured. There are a lot of consideration like dimensional accuracy, geometric accuracy, and the surface finish. All these things is required. There are some general principle, and that has to be cross-checked by using CAD tools. Even you know that nowadays, in order to get the sound casting of your product, so the simulation of the casting process, simulation of the machining process, simulation of your metal forming process, dedicated software is there. That is also CE tools, computer-aided engineering tools, where input is your CAD model. So that is why that is also important nowadays, and that belongs to the CAD CAM tools or CAD CAM CE tools, that different simulation manufacturing simulation tools is also belongs to the CAD CAM CE tools. Now, if you see that I have already mentioned that product development cycle starts with the identification of the need, and which is here I am talking about the product life cycle. So the activity I already mentioned, that it starts with the identification of the need, problem definition, frame out the design specification, then design conceptualization, modeling, simulation, engineering analysis, optimization tool, design evaluation, then design communication. Then it will go to the planning department. As you know, in manufacturing there are different planning, like process planning, capacity planning, vendor selection, tool design, material planning, production planning, manpower planning, and after doing a lot of planning, they will do the manufacturing by real manufacturing process, number of manufacturing processes required to develop a particular product. Then you'll go for the testing, quality control, and ultimately the packaging, shipping, and it will go to the customers, and then self and service, after sales service, and sales after sales services, also the service as well as the maintenance. So these are the total product life cycle or product development cycle, and each and every activity is now assisted by the computer tools. By why computer tools is required? Because most of the new product developer are faces the challenges. What are the challenges faced by the new product developer? So new product developer faces the challenges is, so suppose you have developed a new company to develop a product. What the problem will face? You have to develop your product with shortest possible time, with the lowest possible cost. And your quality should be as high as possible, so that in order to sustain in this competitive market. In order to sustain in the competitive market, if you like to take a successful entry of a new product into the market, you have to develop your product with shortest possible time, with the lowest possible cost, but maintaining a very high quality and reliability. So then only you can get entry in the product. Otherwise, you cannot compete with your competitor. So that means your product unit should be most economic, most productive, and improve the quality. Reason is, productivity leads to growth, growth leads to profitability, and profitability leads to the survival in the market. In order to cope with these three main important attributes, that means you have to develop a product with the shortest possible time, with lowest possible cost, and it keeping the quality high means it should be ergonomically, it should be the aesthetically beautiful, it will be functionally good. Then that is the quality. Now, what you have to do? You have to develop your product with the shortest possible. Hello, am I audible?
Yes, sir.
So if you are to develop your product with the shortest possible time, with lowest possible cost, then how you will do that one? The one way you can do is to first thing is to minimize the time to each and every activity. Product life cycle or product development cycle, you know the different activities. Each activity, there is a involvement of the man, machine, material. That means there is a involvement of the money and the time. So as there is involvement of the money and time in every activity, and if you can reduce a little bit of money involvement, money requirement, or the cost as well as the time to each activity, because money, because there is a manpower, the money, material also money, machine is also money. So ultimately all three money. So if you can reduce the requirement of the man, machine, and material, that means ultimately reduce the money and also the time. Each and every activity, if you reduce that particular both the things, money and the material time, then ultimately your product cost will reduce and time to develop that product reduce, because each and every steps or each and every activity you have reduced the time, and ultimately time and money is sometimes proportional. If you reduce the time, might be your cost will also reduce. So that is why each and every step you have to focus, and you have to see reduce the time involvement or time to complete that particular activity, and with less cost. And in order to cope with this one solution is to achieve this particular objective, one solution is to use as many automation as possible. So automation in design activities by CAD tool, instead of drafting by manual drafting, use the number of your draftsman. It will the cost time consuming as well as the not the cost effective, because you have to take the liability of the all manpower. So that is why if you use automation, that means if you use the CAD tools like CATIA, SolidWorks, AutoCAD, then it will reduce the number of draftsmen required, and the same time it will much faster than the previous. So this is the, and also in design calculation and analysis, if you do manually or if you do the physical modeling, it will take too much time and too much cost involvement. But all the design analysis and you can do over the CAD software using that computer-aided tools or computer-aided mechanism analysis tools or computer-aided finite element analysis, finite element analysis tools, then it can reduce the time to develop. So that are the automation tools in mechanical engineering or design activities, and that is called CAD-C tools in short. Similarly, automation is also required in manufacturing activity. That tools is CAD CAM tools and CAM. Most of the CAM tools, without CAD it will not work properly or not work efficiently. So that is why tools is the CAD CAM tools. Automation manufacturing using CAD CAM tools, and automation in the production management activities is another big issues because a lot of data you have to handle in manufacturing. So there the tools are the PDM, ERP, SCM, CRM, or those who are interested in MBA for them. These are the automation tools for the production management. But here we like to focus on the basically the CAD-C tools. You know, the CAD-C tools, CAD tools is very important because you see the cost point of view. I like to show you on case study here the cost of the change of a design, because design is the iterative process. Many times you have to do iteration because it is not one straightforward. You cannot get the the optimal design. So I just shown here one case study by showing in a nutshell that the different activities in the product development cycle. But I quiz that particular thing, club that thing. Let us say product definition, then specification, design, specification, conceptual design, preliminary design, then analysis, then modeling, simulation analysis, club it here, then design evaluation, process planning, manufacturing, performance testing, full production, and the quality control. These are the activities. Now say the in design, you know that first you have, after doing analysis and all these things, design evaluation has to be taken place. There the many designer will check your design, the different angle. If they found any bottleneck and any mistake, they will tell that you have to rectify that one. Now, if you can find out any particular mistake in the design evaluation stage, then that has to be rectified. In order to rectify that one, there is again involvement of the cost. That means because there again you have to go again to the design analysis and the detailed design. That means there is involvement of the man, there is involvement of the manpower, machine. That means ultimately involvement of the cost. So the cost required to rectify the design or that mistake which is identified in the design evaluation stage is C. Set us a cost involvement to rectify that particular bottleneck or mistake. See if you can find out in the design evaluation stage. Say for example, that particular mistake is overlooked by the design evaluation team, and that has been found, same mistake is overlooked here, but it has been found in the process after process planning. If the same mistake has been found, overlooked at the design evaluation stage and found after process planning stage, already you have involved certain amount of money in the process planning. You have to again go back in the design analysis. Then to rectify that particular problem, if you identify that problem in the after process planning stage, the cost will increase 10 times. 10 times of the same bottleneck or same mistake if you found in the design evaluation stage. Now, see on earth, if you can overlook that particular that mistake only instead of design evaluation stage, or even you can overlook in the process planning stage, it has been found after manufacturing the product during performance testing. Then you have to rectify. That means already you have spent money for the process planning, manufacturing. Now you go to rectification, then you go to the design analysis again, design analysis. Then the cost involvement becomes 100 times more than if it can found in the evaluation stage. And if the same mistake is found in the quality control during then it is 1,000 times more. And if you found this mistake at the customer level or after selling, then you will be nowhere in the market. So that is why this particular case study indicates the cost introducing cost for introducing a design changes will progressively increases or exponentially increases once the development is proceed. From here you can say, from this case study you can say, if you can find out your bottlenecks or your mistake in early design phases, then cost involved to rectify that particular problem will be much lesser than the problem will identify at the latter stage of your product development cycle. So it is your objective to find out any sort of mistake or any bottleneck if it is there. Try to find out at the early design stages. Now, in order so that cost involvement to rectify that one will be less. and that is possible only if you use your concept, if you can change. Previously, there is a concept called the sequential design engineering concept. What is this? After getting the feedback from the customer, marketing personal framework, this is the requirement that will pass to the design engineer. Design in the based on the requirement, the group of designers will conceive the design. They will do all this analysis, and this after that solid model and say the 2D drafting and the bill of material, and they will send all these things to the production engineering department. Production engineering department will evaluate with respect to their manufacturing facility available, and if they found bottleneck, they list down the bottlenecks and they will send back to the design engineering department. Design engineering department will also try to rectify that particular bottleneck what is identified the production engineer. But you know there is a clash between the design engineering and production engineering. The production engineering fellow that thinking the design engineering the white collar job, they are sitting in the AC room, but our room is our environment is not that much. So sometimes there is a personality clash, or sometimes the ego clash, or sometimes if it is a government organization, then a lot of clash. Then what the production engineer, once they rectify this one, design engineer again send to the production engineer try to find out a few more mistakes. So that way it will be an infinite loop. It is a government organization. If it is a private, somewhat is okay. But in this particular process, there is a wastage of time. If you can follow the sequential approach, across the wall approach, then it will go because of this problem. But that concept has been now is broken down. There is no wall in between. Now this concept is concurrent engineering concept. In concurrent engineering concept, the design, the basically all spectrum of expert will sit together at the early design phases. The expert are from the R&D, from engineering, manufacturing, quality control, marketing, sales service. So they are sit together in the early phases of the design process, and they will review the product from the different aspect like design for manufacturing, design for assembly, quality assurance, standardization from aesthetic point of view, ergonomics point of view, safety point of view, reliability point of view, after sale maintenance point of view, process planning, facility planning, capacity point of view, and another most important nowadays tool design point of view, and obviously the functional testing, performance testing, and the cost point of view. So the team of different expert will sit together across the table very early phases of the design, and they will try to review and try to suggest that what are the modifications required. And obviously if you can do this thing in the early phases of design, cost involvement to rectify that one will be less. That I already shown on case study. So that is a concurrent engineering concept, the new relatively new concept in this product design, where expert will sit, and if he found any bottleneck or any possible bottleneck or mistake, thoroughly studied and rectified, and this results in a small number of modification in the design at the stage, and it will reduce the time interval for the conceptual stage to the marketing stage. So that is why concurrent engineering concept is very important concept nowadays. But my question is, if you can place your product or your concept in a 2D drawing, let us say 2D engineering drawing, plan, elevation, side view, and plan number of sectional view, if you can put your concept in a 2D form, 2D drawing form, engineering drawing form in front of the expert, like from the expert, from the quality control, safety engineer, it is very difficult for them to conceive your product. Being a mechanical engineer, many times by seeing only the front view, side view, top view, and the sectional view, we are unable to conceive the product shape and size. So how can we expect that those who are not mechanical engineer, they can conceive your product? So that is communicating your concept is very important nowadays in order to implement concurrent engineering concept truly. And for that, the tools is CAD CAD tools, because you know the picture, the 2D picture, the 2D say the more than 1,000 words, but model, 3D model tells the whole story. So that is why the tools is required. Modern context is the virtual prototyping tools using CAD CAM C, and that is I'd like to show here the power of 3D. Here, whatever example I'm showing here, all are the 3D model of the product, not the your physical model. So if you can place this type of model, digital model in front of concurrent engineering team, they can easily conceive your concept, and they can properly evaluate your concept instead of taking the 2D drawing. So that is why very fast step of the CAD to develop your 3D model of your product, because we mechanical engineer dealing with the product which have definite shape and size. If you had a definite geometry, definite size, then you have to develop a model of that one. And in order to develop that model, you need solid geometry concept. That means what you have learned in your mathematics class. So CAD software, the backside of the CAD is full of mathematics, because any geometry basically mathematically represented by the solid geometries or whatever you have learned in your engineering mathematics class. Solid geometry are different equations, and equation has to be written in coded form, and that is why solid modeling apparently looks like it is the software work, but inside backside the full of mathematics. So CAD software, if you see, it is the full of mathematics backside, and you have to developed, whether you like to develop CAD software or you are the user of the CAD software, whatever may be the case, you have to know the fundamental of that solid geometry by which a geometry can be represented mathematically and ultimately in a graphical form. And solid modeling is the very first step in your CAD applications, that develop the CAD model or 3D model of your geometry or for your product, so that you can implement your engineering concept more efficiently. Okay, sir. Today I like to stop here. If anyone have any query, so if you have any doubt, you just tell me. So tomorrow we'll continue with the. Today is the introductory part of your CAD. Means that I like to emphasize why CAD is important and what are the steps. CAD doesn't means the drafting. So it's my more thing I like to mention. The CAD is not for draft. The CAD is not one. It's not a drafting only. So drafting is very maybe the 1% of the total CAD. The AutoCAD is 1%. AutoCAD requirement is 1% in the whole CAD. CAD starts from your mechanics to the little more is there that I will tell. So if you have any doubt on that, anyone? Dr. Ashish? Hello? Hello?
Yes, sir.
So today I like to stop here. If anyone have any question, just ask me. Otherwise, I like to stop here today.
Okay, sir.
Okay, you don't have any query or any question?
No, sir.
Okay, thank you for your patience. So tomorrow once again we'll meet at 4 o'clock.
Thank you, sir.
Okay, thank you. Bye.
Thank you very much to you, sir.
Yes, sir. Hello. Hello, sir. Hello.
ओके सर लीव
Yes,
करते हैं
sir.
सर सर चले गए हैं सर